We have more examples on distance time graphs. As you see here, we have two distance time graph. In the first distance time graph, let us denote it by give it a name, distance time graph 1. Here we have distance time graph 2. Okay, here in the y-axis we have distance in kilometers, and in the x-axis we have time in minutes. So first let us describe the motion of this object. Let us name these sections, guys. So here in the first section, let us say this section here is A, and this one let us give it B. This one here, let us give it C. Okay, in section A, to describe the motion of this object in section A, let us assume that this is a distance time graph for a car that has been moving for 5 minutes. Okay, in section A, this car was moving with a constant speed for 2 minutes, and it covered a distance of 4 kilometers. As you see here, the end of this section here, it's here in this point, which is corresponding to 4 kilometers. So here, straight line, that's mean what? In a distance time graph means a straight line, a constant speed. So here, the car is moving with a constant speed. So to find the speed is equal gradient, and gradient equal rise over run. So here, what is our rise here in this section only? The rise here is, we're gonna find it in the y-axis, which is the end point of the line, which is corresponding to 4 kilometers. So speed in this section is equal 4 kilometers. So we have to convert the kilometers to the standard measurement unit for distance, which is meters. So 4 kilometers is equal 4,000 meters divided by the run. The run is on the x-axis, which is time, and time here also in minutes, and we have to convert it to seconds. So this car has been moving here in this section for 2 minutes. 2 minutes, to convert 2 minutes to seconds, we multiply by 60. So 2 times 60 gives us 120. So the speed will be 4,000 divided by 100, which is equal 33.3 meters per second. So this is the speed of this car on this section. So let us go to section B. In section B, the speed, we said that before, a horizontal line. If you did not watch the previous parts, so we said that a horizontal line in a distance time graph, pay attention, a horizontal line in a distance time graph means what? Means the object is stationary or is stopped moving or fixed. So here, this car is stationary. That means it is not moving here in this section. So from the second minute to the fourth minute, the object was stationary. So in section C, the object increased or changed its speed than the initial speed that it started its motion with. So here it seems the object was moving with a large speed. So this line here in this section starts from 4 kilometers and ends at this point, which is corresponding to 8 8 kilometers, which is 8,000 meters. So the speed here will be 8,000 divided by what, guys? Not 8,000, sorry guys. So in this section, guys, in section C, in section C, the object started from this point and ended this point. So here we have the end point of this section is corresponding to 8. And from this point to this point, that's mean what? That's mean 4 kilometers too. So it's going to be 4, I'm going to write it here, 4,000 divided by what, guys? By the time here. The corresponding time to these points is 1 minute, as you see. 1 minute is 60 seconds. So because why it is 60 seconds? Because we converted minutes to seconds. So 4,000 divided by 60 is equal 66.7 meter per second. So that's our a speed in this section. As you see here, the object has changed this speed because this line is more steeper than this one. So that's why the speed here is higher than here than this section. So the speed here, the size of the speed is more larger in this section than in section A. So this is in the distance time graph 1. Okay, going to distance time graph 2, let us delete these. Sorry. Let us delete this 2 here to save some space. So here in this section, also let us name these sections A, B, C. So this is our straight line which represents the motion of the object during this first 2 minutes. So in this point the object stopped moving. So it covered a distance of 0.6 kilometers. Pay attention to the units here. So it is 0.6 kilometers. So here the speed is equal rise over run, or equal the gradient, and is equal rise over run. So our rise here is corresponding to 0.6 kilometers. So here is speed is equal 0.6 kilometers divided by the time of the journey during this section, or in this section. So it is 2 minutes. So we're gonna do the same thing. We convert the kilometers here to meters and time in minutes to seconds. So here, let us write it here to save some space. So the speed is equal 0.6 kilometers is equal 600 meters divided by what, guys? 120. And this is equal what, guys? 0 cancelled, so we will be left with 60 divided by 12, which is 5 meters per second. 5 meter per second. So this is our speed in this section. So section B also, we said it's a horizontal line, so it is in this section the car was stationary. So in section C, the speed in section C is equal what? Okay, when we have a line like this, a line that goes down like this, that's mean what, guys, in a distance time graph? It means the object, it's going back to its starting point. It's going back to the starting point where it is started its journey. So it's going to the initial point where it has moved from. So here the speed in this section it seems more the object is moving faster in this section than in section A. So the speed in section C is equal rise over run. So the rise is here also. Rise is here. So which is 600. Why the 600? Because we converted 0.6 kilometers to meters. So 600 divided by the time, which is the time here, guys, the time here. This is the time here. Because the entire journey from this point to this point was in just 1 minute here. Because from 4 to 5, it was just 1 minute. So 1 minute is equal to 60 seconds, which is equal 10 meters per second. So this is our speed in section C.